SQL scaling problems and how to replace most of what NoSQL has to offer. Today I try to concentrate on how to use Postgres itself well and how to make it as seamless from Python as possible. So I guess that some of the people were not here yesterday, so a few first pages are the same, but it will diverge soon enough. So my name is Krossing. I currently work at secondquadrant.com. It's a postgresql consulting company. We help people who have scaling problems, performance problems, other problems. Not that Postgres has that many problems, but when you are trying to push the edges and to really high loads, then sometimes expert help is needed. I've been user of both Python and Postgres for quite some time. I started using Python since I think it was version 1.1. Linux was then before version 1. Postgres was actually called Postgres 4.2, and it didn't use SQL as its query language at that time. It used a language called postgresql. It was kind of SQL-like language, but it didn't say select, it said retrieve and so on. So it was a version of NoSQL at that time. And I currently also I also work at Ambient Sound Investment, which is the company run by the Estonian founding engineers of Skype. They made a bunch of money from Skype, and now they are also investing this into startups. And I first met really big databases when we started at Skype. We started ordinary, just one server, then two, then three, and during my time there, we grew up to some 50 or 60 servers. Now they have more than 1,000, all running Postgres, all tied together by Python scripts and then some homemade tools. When we were there trying to figure out how to scale things, I invented a language, Proxy, which was, again, prototyped in Python. But eventually we made it into a separate language, and so everything there is partitioned to this language. We'll also, at some point, speak about this. I've written one book. The other one is from, the first one I wrote together with Simon Riggs, who is a well-known Postgres hacker and the founder of Second Quadrant. The second one is also by a fellow Second Quadrant member, Craig Smith, and currently I'm writing a book on PostgreSQL server programming that should be out later this year. It has also a chapter on Python. Okay, I'm from Estonia, and we are mainly known for two things in the Azure world. We are a very small country. First we destroyed Soviet Union, and then we wrote Skype. There's not much other things that Estonians are known for. Both of these were, of course, tried before, but no one was successful. So we made it finally. So let's first have a small introduction about Python and Postgres, how they are similar, how they are different, and how to make them work well together. So I don't think I need to actually introduce Python, but I'll bring out a few important points. Python is dynamic, strongly typed, even though some say that it's not strongly typed, but all the objects themselves have strong types. They don't change their types like chameleons from one expression to another. There is quite good introspection. You can, if you get any kind of Python object, then you can deduce quite a lot of it. You don't need to know beforehand what it does. There are few places where you don't get everything, but that you usually get enough so that you can write metacode that deals this way or that, depending on what it gets. It is interpreted language, at least the main C Pythonese, and some of the assumptions about the language are also based on it being interpreted, so I don't think there will ever be a completely compiled Python. And Python is extensible. First, it's extensible by just writing new Python modules, but you can also write C modules, either in pure C, which is quite tedious, but nowadays there are more things like Python or Swig for wrapping other C libraries and thus helping them to become Python extensions. So for Postgres, you notice that at least here nothing much changed. It's also dynamic. You can add and define data structures, functions, views in runtime. It's strongly typed, even though here it is different from Python. The strong types are not tied to the data itself, but they are tied to the fields and tables the data is stored in. So to know what type the data is, you usually need to know where it is. You can't just get an item, even though in most protocols you actually get enough info to know that this is this kind of data. It has also quite good introspection capabilities. It has the standard SQL views for learning about what kind of tables you have, what data types there are, and it has also its own extended system directory, and it comes to this introspection feature is kind of free result of being extensible, because almost everything about PostgreSQL is defined in system tables, in the PG catalog tables. Even what type act what way, in this way it's even more dynamic than Python. You can, for example, have your own integer type and then replace the main one and have it behave differently, even though I'd advise against it. If you need your own types, then don't replace the system ones, but just add things to them. And it also, you can claim that it's interpreted, at least the main part of it, when you send so-called queries to it, which usually are in form of select, insert, update, delete, or then data definition language, which then create objects, or data access language, where you can give rights to objects and so on. So also when interacting with Postgres, you send it commands, and Postgres then passes and interprets them.
Sorry, the audio level is very low in the back of the room, so can you please use this?
Okay.
Thanks.
No, should I keep this also on?
Thanks, sorry.
Okay. So, and PostgreSQL is the database server, and it supports ACID. Here is where it's quite different from Python. ACID means that all operations are atomic. If you do something, then it's either all done or none of it is done. Consistency means that you have either command level, or you can define transactions for a larger set of commands. And at the end, there are certain set of rules, some implied by the database itself, and some you can define that are guaranteed to be followed by the end of the transaction. Also, the transactions themselves are isolated, which means that when you are done, only then the other users can see your changes. And also when something is stored, then the data stays stored. It is guaranteed that unless your whole system breaks down, you can always get your data back. So Postgres is actually not any kind of system. Well, Python is not any kind of system. Python is a language and also a language interpreter. So mostly we think of them as the same thing, but they are two different things. Depending on what context to use Python, it can be either of these. And it doesn't seem to have any concerns about ACID properties. It's just out of scope for Python. It doesn't even have atomicity at a single command level, as you can see in this example, where you, depending on what order you do, both of these statements fail, but in one case the variable actually gets changed, in the other it does not get changed, which means that when you start using them together, then this is one thing you should take notice of, that the data handling properties of the two systems are quite different. Python does it just in some order, and when it breaks, then it breaks, and you can catch the fact that it broke, but it doesn't mend anything it broke. It just returns you the data as it was at the moment when it broke. So if you have some serious data processing needs, then Python, you either have to write your own code to take care of these needs, or you need to use some system, some external system or some ready-made libraries to take care of this. And the main needs when these things become concerns is when data needs to be persistent, that you need to make sure that when you actually save something, then the next time you start the program, it is there. Also, when the data is accessed at the same time by external entities or just by the second copy of the same program. Also, when you need to make sure that some other programs don't get partially written data or partially changed data. And if you have some rules that must be considered inside the database. Atomicity at least can be done quite easily by saving the new data into a new file and then renaming the file, because at file system level, at least on Unix, the rename command is atomic. It either fails or it succeeds, but it can't partially succeed. So you have a way to do at least atomicity, and if you have atomicity, then also the other things are possible to build on it. But it's much easier to use something that is already made to provide this. So Postgres is a relation database, which means that it provides ACID, it stores the data in tables, it can combine tables in views, but also some things that are not available in all relational databases, but which can be said to be specific features of PostgreSQL. It has functions, it has pluggable languages, and you can extend it in multiple languages, not just Python, not just SQL, not just C. And it's also a server, which means that you even don't need to run any. It's not only good for data manipulation. You can use it just as any compute server. And for example, for me, it is the easiest way when I need to do some multi-language programming. Say if I have one library available in Perl and the other in Python, and I want to call functions from one to the other, then I just install both languages in Postgres, and it's quite easy to use one from the other, even without needing any data operations at all. So when the data is on server, then most often you think of processing the data, that you download the needed chunk of data to the client, then you process it, and then you upload the results back to the server. And this works quite well. Sometimes you have to take extra precautions, for example, to lock the data for the duration of the processing so that someone else doesn't do it. Locking the specific piece of data is easy. You just put it in transaction, and instead of select, you say select for update, which means that until the transaction end it stays locked, and others, they can't change it, and then when they read it, they get the older version that is not changed. If you do distributed computing, then the data is still on server and it can stay there, and instead of moving the data, you move the code to the server. So it's in limited way it's available in SQL. You just, for example, update the row on server without loading it to the client. So here how you do it in classical Python DB client application. You make a connection, then you make cursor, and then you send the SQL command to the server. If you use some object relation mapper like Django, then it's not really much less code, but it's much more Pythonic. You define your model in models P file, and then you in your actual production code you first import it, then you initiate the proxy object, you change the attribute, and then you tell the system to save it. In the background it still does the same as in the first sample. It loads it to the client, it changes some data, and then it sends an update statement back to the client. So what if you don't like to and the same thing is if you do it in PL-Python, which means inside the database, then currently it looks like this. You first prepare a plan, or you could have also executed it directly with the numbers there. And one thing to see here also is that PL-Python does not use a DB API 2, it uses its own very simple API, and sometimes it's even preferable if you want to do it the SQL way. There is a guy called Peter Eisenstraut who has actually written a DB API wrapper for PL-Python, which works quite well. So if you have some code that uses DB API, then you can download it and use it as you would use it from the client. Okay, here is this link also. And for doing it the object relation mapper way, there are some other object relation mappers, SQL Alchemy, Storm, SQL Object, which is almost not used anymore. But the main problem to object relation mappers is that they, if you really don't take care, then they can make lots and lots of SQL requests. And also most of them are written to be very generic, which means that they are written to the least common denominator, and quite often they try to get away with the simplest SQL they can. Which also means that less featureful databases are kind of preferred. And most object relation mappers have also ways to circumvent this and even write their own SQL either in classes or as some kind of additional wrappers or mix-ins. But then if you already write SQL and put it in ORMs, then why use the ORM anyway? And if you use obvious relation mappers, then it's not very easy for DBA to go and fix inefficient functionality in database, because the database code actually is mostly in client side. And also you can't easily start partitioning the database, which you could do if everything were written on client side, or in the server in functions. Is this many requests really a problem? Just today morning I looked up one of my own Django applications which does a simple form. It returns a few tens of rows of a table, and it does 380 separate database requests. I know that it could be optimized, but it does this all in 2 seconds, and it doesn't have very many users, so I haven't bothered to go and optimize this. But it still is much slower than it should be, or it could be. And also this is something that usually doesn't show up at development time when you're only user. Mostly on today's hardware you can afford to be a little bit slow. And you could optimize and force things to be faster, but what happens then is that you have to do quite a lot of extra work. And the main thing that happens here is this latency, which means that it's not the client that is doing much work, it's not also the database that is doing much work. Most of the work is actually, most of the time is taken up by the communication between your application and the client. So in database, when I checked, most of the queries took a fraction of a millisecond, and also even the slowest ones were 1 or 2 milliseconds, but still it all together on in over 2 seconds. So here I made a sample. To demonstrate this, I made a sample schema. It's some order items and so on. It does, first it's in Django, it takes orders, and then saves back the changed availabilities and order lines. And when I did this, it takes at least 500 milliseconds, usually more. And you could avoid some by getting more at the time, but it still doesn't work very well. The same written in EuroPython, depending on the run times in Postgres are quite variable. If you test anything, you should test it multiple times to get any reasonable expectations, or just if you optimize something, and also you should run it a few tens of times at least to see if anything got better from your optimizations. But anyway, it's just a few tens of milliseconds when done entirely in EuroPython, even though it does exact same queries, or all these 300 plus queries, but because it skips the latency, you get a much faster runtime. The problem with EuroPython approach is that you maintain the code in 2 places, and it's also hard to write. And you would want to still to have just a function from the client side where you write something, and then you don't really want to worry about connecting to database or sending queries, reading back the answers. And one way to do it is to write a decorator which you just wrap around your Python function, and then this decorated function will be executed not on your client side, but it will be shipped to the server and executed there. when researching this, I found out that you can easily get the code object from the function. It's marshallable, so you can back it up and send it somewhere else to be executed. And basically here you have decorator as a class which wraps a function, and when it's run, then it automatically executes it in the database, sends the JSON encoded arguments, and gets back the JSON answer. And you need to have a simple run code function inside the Postgres database, which basically fetches the marshalled code object. It also decodes JSON arguments. Then it gets the code, defines dummy function, attaches a code function, and then calls this function. And here is how you would write the same processing function now in your client side. And then you don't. And if you have these kinds of decorative functions, then you can do all your development in client. You don't have to worry about changing functions on the server or managing the versions there. You just have one code page with some functions executed in the client, some executed in the server. And when I tested it, then the large portion of the overhead is actually in the calling, but it's still it's not noticeably larger than just calling the similar functions without shipping the code. So for any reasonably sized code, the actual code shipping and instantiating doesn't take any noticeable time. And it's still orders of magnitude faster than running the similar functionality or separate queries from the client side. Yeah, okay. Now I have a few versions where I actually don't use a single code running functions, but in fact I create the function on the server side. So first I try to run it. If the function does not exist, then I create it and run it again after creating it. This is also something that is much safer to do on production systems, because then you have a control over who can create new functions, who cannot. But still the main development cycle will be similar. Again, when you do the development on client side, it's still just a decorator and your function. And when you call it, then you get back the results that are actually evaluated inside the database. And the database function doesn't look very much like what you'd expect the PL-Python function to look like. It actually has the code object obfuscated. Some people may like it, so they think that the client does get the code, which is not entirely true. Most Python decompilers can get it quite well. But at least you can think of these as compiled functions or semi-compiled functions in the database. And here is a third way to do it. If you want to scale these functions using PL Proxy, then we need something in the signature that PL Proxy can distribute these functions based on, say, username or some other item that is used as the distribution key. And basically it does a little same thing as the last one, but only a little bit different. It also has a distribution key as an argument, and it creates a function that looks similar to the last one, only with the only exception that it also includes the key you can partition on. And when you already when you have these kinds of functions, then you can use the PL proxy language to distribute the calling of functions over several databases. Basically, PL proxy is a simple language where you just say the language itself has a keyword cluster which defines a cluster, and then you say that run based on hash text username. Actually, this e-username should be here, this part key, not the username. It is a copy and paste error. But basically, this is how it looks like, and this can then be scaled to tens and hundreds of servers and then run on the right place. And the difference between scaling these kinds of functions on PostgreSQL and scaling most of the NoSQL databases is that usually you keep your related data together, but they are still in normalized form and usable by multiple objects at the same time, and there is no duplication. Okay, I started out trying to do with the aim of doing it for Django. This has not yet advanced very far. I have some limited Django-like object relation mapper tests, but it's not really very far. This is what needs to be done. And the PL Python is quite primitive still, so some things that are missing and on which I am currently working is one is that you should be able to import modules from database, which means that you could have a table, otherwise you must always coordinate your Py modules on your development server, on client side and the server side. It's not very hard to actually have a database table where the modules live, and so if you import something in PL Python, then you can you don't need to go to the file system. More complex thing is importing modules from client side. I have some proof of concept implementations where the client just where the server code comes back with specific exceptions and tells which modules it needs, and then you move more of these to the server side until it succeeds. It's not very performant, but it works. There is no way currently for direct function calls on standard PL Python install. This one I actually also worked around. I have I go for this and then I show you. Also, the simplified access is the same as some object relational mapper. Currently, I'm looking something that will look a little bit more like jQuery than the classical ORMs, where it should be quite Pythonic access script, but the basic thing is that you don't need SQL for simple things. I think SQL is a very powerful and good language for complex analysis tasks and for querying, but for just updating one field in one table row, it's not the best thing. It's usually too verbose, and even there it's sometimes easy to mix things up. And also I'd like to have some startup scripts or startup modules, so when you first load PL proxy language or you call your first PL proxy, not PL proxy, PL Python function, then it should be possible to specify that some modules should be loaded already or some scripts run. Another thing that I have briefly looked at is that you don't need actually to generate SQL if you are already inside the server. Then instead of generating SQL from your object relational mapper models, what you could do is generate the query plan directly. Currently it first generates SQL, then the system passes the SQL back to query plans. It would be much nicer if the query plans were made directly. And also the whole thing could later be extended to other languages, Ruby, JavaScript, and so on. And the conclusion is it is quite possible and feasible to write all your code in Python and then just have some functions automatically be shipped to the server side. It's in this way it's similar to object relational mappers, that only that you don't execute SQL, you don't execute simple SQL, but you can send complex Python functions over to be executed on the server side. And I'd like to get it more integrated with Django, so that the end goal is actually to have a possibility to decorate the Django method and then have all of it run on the server side, up to generating even the HTML from templates. This needs a few other things I mentioned to be in place, like importing from the client side. Also, the template loading should be then be made, should be able to call back to the client and get the templates. Okay. And here is how to reach me. Basically, hannu@secondquadrant.com, and also you could try my Skype Krossing, and if you have some quick questions. Or just the first one is also, if I don't find a way to put the slides up, do we have some way to put the slides up? Also, okay, then they will appear somewhere on the EuroPython website sometime. Okay, and now I'll have a small sample of how you can do direct function calls in PL Python. So first, to make it so that you can do this, no, I think you don't have too many. So I attached some code to the PL Python. It's no I didn't do any modifications to PL Python itself. It's all done externally. So, and the interesting part here is that I can directly call any function. I can put some other function there, and it will get called by itself. Let's see what functions there are. Okay. You can't return things from this do construct in Python, which is for directly executing pluggable language code. So I use the notice construct that actually sends it up as an error or warning message. But basically, this gets you can call directly any functions from Python. And so how I did it, First I tried to use Python startup. Of course it didn't work because it works only for interactive Python. Then I set the Python verbose to a large level and looked up what modules were imported. And then I selected this module and put some code there so that it so basically it checks that you are inside Python by looking at environment variables, and if you are, then it imports built-ins and attaches something to then it actually if you are in, then it executes startup functions from your database directories, Python directory. And because not everything was available at that time, and I had to make a special loader module, which at first calls replaces it to the real worker module. And so when I call this when I call PG, when I call PG clock timestamp, then the first time the clock timestamp is looked up, I actually instantiate the real worker module, look up its clock timestamp function, and I also replace the loader module with the real worker module. And the worker module is a simple one. It just remembers the attributes you did lookups on, and it has a call method which then figures out the path that was attached to the PG, and then constructs a select statement based on this. It will be select star from function name arguments, and then if it's just one row with one argument named the same as the called one, then it recognizes this as a scalar function and returns only this answer. Otherwise it returns a set of rows. So it was actually, I think it was 2 days of playing around, but I did get it to work. And I think getting the import hooks working is also probably 2 or 3 days work, so that you can do imports from the database. And so for most of the other things, I think they are half a day or day of work. Some are maybe more, some more complex things. Especially the callbacks, I think some of them, to do it properly and high performance, requires even some changes in the client library side. So perhaps not use the PsychoPG at all, or use something like PG 8000 or some other PyPython database adapters. So I think this is all on the presentation side. I'm now open to questions.
Okay, I'm arriving with the microphone. Very close.
Hi, can you please return to the slide where you show the function which is executed on the server side?
Which ones you mean? The remote one. The remote one, where I do the decorated one, or?
Yep. Maybe.
Okay, this is the decorator, and this is how it's run.
One more back, or maybe two. Yes, one more. Sorry. You actually show the function which executes on the server side. The code of the function.
This is the one, the simplest one to execute the remote.
The client function which you pass it to the server side. Yes, this one.
Yes.
The uppercase SD. Where is it defined?
SD. These are PL-Python. PL-Python has two dictionaries by default. The one is GD, that's global dictionary that is available to all PL-Python functions inside one backend, and SD is a local dictionary available to all invocations of the same function.
Okay, so this is global variable which is defined on the server side.
Yeah, this is the server side. Already the whole code here is on the server side.
Okay. Do you pass any global variable which is defined on the client side?
Not currently. It is the whole global thing is currently lost. They are separate on client and server. Mm-hmm. Yeah.
Is the directly submitted function after the call automatically removed, or does it still exist on the database server? I mean, you always used in create or replace. Does it mostly mean if you once called the function, it will always be replaced and your database?
No, here this is just from my development. This needs to be created only once. This one. It is meant to be created once on the server, and later it just gets the code in this code64 object, and it executes the code already. The function itself stays the same, if I understood the question right.
So the function that is uploaded with run code is not actually stored on the database server, it's just sort of evilled?
Yeah, in this most simple version it's never stored. I have also played with versions where I keep the function codes in a dictionary, in Python dictionary. And the next ones actually generate PL-Python functions where you have, even though the function code is still there as a base 64 string inside the function. But it's at least it's persisted in the database that way.
Newbie question here. I'd like to know, when executing Python function server side, do you bring up every time a new Python interpreter, or do you have a process pooling, something like that?
The Python interpreter, actually the Python library, embedded Python library, is initialized the first time in a connection when the first Python function is run. So Postgres' process model is so that each connection gets its own separate backend, and that the first time you call a Python function, this it is initialized.
So Python is embedded in Postgres?
Yes, it's in the same process, and it runs in the same process space.
Any more questions?
I've often been envious of the .NET people with language integrated query, LINQ. This looks like something that could be used as the basis to do a link-like facility in Python.
I am not. I don't know about this NLP, but that most likely it can. Yes, at least by the name, it seems something similar. So that you actually can send some more complex things to the server to be executed there. Yes.
Thank you.
Mm-hmm.
Any more?
Yeah. Okay. In one of your first slides, you show a piece of ORM code from Django.
Yeah.
And said that by calling save after setting an attribute to a model instance, you were doing the same just like an update statement of a single field in a database. But that's not how it is, because when you call save on in a model instance of Django, you're actually setting all the single columns. So you're doing an update of each single field in the DB model.
Yes, no, basically I don't think that it's much difference, because most of the latency comes from the fact itself that it is sent not by the amount. Maybe it is a difference if you have really large fields.
Well, apart from the difference in performance, there is a difference in because you're setting also the other fields, and maybe some other thread or some other process have changed these fields already. So it's just something I want to share with other people that that bite me in the past as a newbie, that I was calling save. I thought, well, then maybe Django is only saving that single attribute that has changed, while it saves the whole thing.
Does Django have any means to do it atomically, like the first to select for update or something like that?
Yes, now yes. In 1.4, yes.
Okay,
you can do that.
But not before, yes?
No, on 1.3 no. And while, for instance, Mongo engine, that is a different ORM for Python, for Mongo, that doesn't have nothing to do with this, but has the ability to understand, to update only the single attributes that have changed in the instance. So when you call save, it only updates the single attribute that has changed.
I did some reading up on Mongo, and it seems that if you wouldn't do it that way, then it would just clear out everything.
Yes.
So, yeah.
You had a question?
Okay.
So how much was the real speed up you gained from transferring these functions to you show some numbers, but I couldn't see relate them.
The real speed up was about, no, it depends. If you do, if in real life you do very many small queries, then it can be 100 or 200 times. But if you do anyway only 2 or 3 queries, then it's not much. So it depends on what kind of processing you would give there. The main speed up comes from for not causing the latencies of database and client communication. And I hope to make it more or less transparent for Django, so that in the end you don't have to do all the Django tricks to force larger SQL code to send, or also you don't need to pay attention to caching, for example. So if you don't do anything in Django, then you repeatedly end up fetching the same values. For example, if you look up something in your template. And then if you do it from client, then each of these causes round trip to the database. If you do it inside the database, then the round trips, it still does queries, but they are so fast that it doesn't matter. It's not big difference if you look it up inside Python or using a query. So it can be significant, but it depends on how many queries to the database are generated. And usually when you do SQL manually, then you are more aware of it, that you are doing lots and lots of updates. Even though if you have some fat library, then you may not be aware. But if you write direct database code, then you mostly know that now I'm doing so and so much database accesses.
Okay, so thanks everyone for the question. Now it's time for you to check if you want to go in another meeting or not. The question time is finished, so I thanks everyone for being here, and thanks for the speaker for this very special talk. The speech was really interesting.